Thank you for joining this lesson. We're going to study angle properties of a circle, chords, and tangents. We are told in number 19 that in the diagram shown below, O is the center of the circle, then angle RTV equals to 150. So RTV is 150. And angle RST is 50. So those two angles have been provided. Then we are told to calculate the size of ORS. ORS, the size of this angle. So let us look at the procedure which will take us to this angle. Okay, we know very well that SV is a straight line and we have 50 here. The angles on a straight line must give us 180, so which means the angle here is 30 degrees. Now that we have 30 and 50 and SRT is a triangle, then we can get the angle just here. So the angle there is going to be, this is 80, so 100, because they should add up to 180. Remember, if it was about getting R, we can, the angle at R that is, we can again apply a mathematical concept whereby we say the angle which has been made by a chord, for example RS, and a tangent UV, that angle will be equal to the angle produced by the same chord in the alternate segment. Therefore, at P, we have an angle of 50 degrees. And at the same time, I'll apply a property which says the angle at the circumference is equal to half of the angle at the center of the circle by the same chord. So this will be 100 degrees because it is angle subtended at the center by a chord and 50 at the circumference. So this angle should be half this, or rather, the angle at the center should be twice that at the circumference. Therefore, this becomes automatically 100. Remember, we have 100 and this is radius. This is also radius. So which means in this triangle, OSR, which is isosceles, then we should get 180. So which means the 80 which has remained, we will divide 40 to this part and also 40 to this other part. Therefore, now we are having 40 degrees here, 100 degrees here. Remember, this is a straight line, so 140, we should also get a 40 here. So this is another 40 degrees. So the angle we were to calculate actually, ORS is already given as 40 degrees. So that angle is 40, owing to the fact that this is an isosceles triangle. The base angles have to be equal, and inside the triangle we should get 180. Therefore, this being 100, we share 80 into 2. Okay, the second one, USP, this angle. There is a property we have applied, and we are going to apply it. We have just said that the angle produced at the alternate segment by a chord is equal to the angle made by the same chord and a tangent. So we apply the same. The way we have concluded that this is 50, just like the angle here, then we have a chord PS making an angle, then chord PS is producing an angle of 80, the whole of this angle. So PS produces an angle of 80 in the alternate segment, which means the same chord should be leaving 80 with the tangent. Therefore, we have an angle of 80 degrees. 80 degrees. PQR. So for PQR, we're going to apply cyclic quadrilateral, whereby we say opposite angles in a cyclic quadrilateral should add up to 180. So this angle is opposite to the angle here. Therefore, they are supposed to give us 180. Therefore, we can know the angle here because we are having 80, and this one is unknown, this angle should be 10. Because this is a radius, and a radius and a tangent makes 90 degrees. Therefore, from the 90 degrees, we have already 80 here, so this is 10. Now that we have 10 and 40, the whole of this angle becomes 50. And now that this is 50, and we want its opposite, then this angle should give us 130 degrees. Therefore, the angle at Q should be 130 degrees, because it is opposite angle in a cyclic quadrilateral.